Hi, my name is Ted Cross, and I'm a technical advisor with Novi Labs. Today, we're excited to release V1 of Novi's data engine. We've taken our 6 years of experience in handling, processing, joining, and transforming oil and gas data and put that into an easy-to-use graphical user interface. Data engine enables the building of high-quality, analytics-ready data sets. For V1, we're starting at the beginning, uploading, mapping, and formatting the source data. Here, you can see on the left, we're supporting 4 different source data types: headers, production, directional surveys, and subsurface. To begin, I'm going to go up to the Create button on this Header Sources tab and choose the file that I want to upload. I just have a download of header information for the Utica play as of September. So I'm going to go through and open that up. The way that data engine works is that we have a variety of known output fields that we know how to handle. Things like regions, formations, spud date, frac dates, lateral lengths, and completions information. We allow you to go through and for the input fields that are present in the source data set, map those to the known Novi output field. So here I choose that proppant pounds column. It's in this particular format and the units are in pounds. Anytime you map a column, it doesn't just associate that known format and units with the column. It also goes through and checks whether the numbers or strings are valid and whether there's anything that's empty. If you want to see which ones are empties, you can click on that and see how it looks. I'm going to go through and show you what this looks like when it's all gone ahead and been finished. So for this data set, we mapped 17 of our optional Novi fields and 24 user-defined fields. And you can see for the vast majority of these, the fields are perfectly valid. We have 2,588 rows, and we're getting up to around 236 missing there for lateral length. We also have a number of ones that are mapped into here. So, for instance, we have drill time as a column. These user-defined output fields will still get passed through to your final data set. If I wanted to go ahead and replace this with a data set from October, I can go through and just kind of choose that data set. So here I have my October header attributes, and I'll retain all the same input mapping that I had previously, except this time it's going to go through and once again check the validity and for empties across all those different data types. So it's very easy to reuse the mapping that you've already done on stable schema. Okay, next up I'm going to go over to the production tab. This looks very similar to what you had on the header information, known output fields, except in this case we have things like production streams. We also have days online. That's important if you're trying to normalize it between monthly and daily production. And we can handle different data types here for the production. We can handle dailies, monthly data with a single date field, monthly data with separate month and year fields. For directional surveys, looks similar to the two above, except again, you're mapping different input data types here, things like position, inclination, azimuth, TBD. Subsurface works a bit differently, and a lot of the reason for that is that when you're uploading subsurface data, a lot of the time it's coming as a collection or a zip file of a bunch of different subsurface grids that have a similar structure. So here I've zipped together 3 different grids, permeability, structure, and net porosity. I also have a few, when you zip something up on a Mac, you get these little hidden utilities. You see those little Mac OS X files there. Software recognizes that those aren't XYZ grids and says there's an error and it's not going to get passed through. The way that the subsurface sources work is that you map an EPSG or a coordinate reference system. Here, these are in WGS84 that has a format. You choose the X field, the Y field, and the Z field that are present in the data set. Give it a name, something like net permeability. Make sure it's reflecting what it actually is. This is for the Utica formation, and it's a net permeability rock type. And those will get used later on in the process. Okay, so I'm going to go ahead and hit save and next there for that one. Anytime that it's going through and doing this mapping, it'll also let you know, it'll give you a little preview of where the file is on the map. So Here for the structural depth file, you see very, very kind of simple geologically. It's depth, it should be simple. But the point here is for you to be able to just make sure that everything's loading in the right place and that the grid actually looks okay. And for my third file here, I have a net porosity map. And you see that one where that one's loading. Okay, everything looks good. I'm going to go ahead and finish that off. Okay, so just now I've showed you the data source uploads, which we support right now. So this is live in our software. Presently, we're working on allowing users to create sets of those source data types. So if you have multiple well header sources, let's say you have a public one, a proprietary one, we allow you to join those together to make a well header set. Similarly for production surveys and XYZ grids. And then those can be combined to create data sets, which do the joining of those different data types together, also allow you to configure spacing and publish the data set to Novi Cloud. Let me show you how that looks for the data sets. For this one, let me go through. I'm going to open this one that we've already shown. All this is schematic format. So this part was live code down here in the sources. Now we're looking at schematics that we're actively working on. This part should probably be released in later this quarter, possibly the last bit in early Q1 of 2021. But active effort from our software development team. And here again we have the known output fields. These are similar to the ones you've already mapped down on the source level. But in this case we have a merge order of different sources. So source 1 might be your private data, source 2 might be a public data set. And as the software is merging together the values for these columns, you may have the same wells represented across multiple of your input sources. And if that's the case, you can use confidence order to merge those together. But you also want to include an additional layer that it's possible that your data is invalid within that first one. Maybe it could be the latitude and longitude just aren't reasonable, or the proppant value is impossible or negative, something like that. In that case, you want to skip over that one and look to the next data source. So that's what we allow here with the rule and the merge order. In these two columns over here on the right, it shows you how many of the wells failed the rule across all of the different merging data sources. And then how many of them were just totally empty across all those different data sources. Again, the theme is we want to surface any issues with the data to you as early as possible so that you can remedy that before you actually get to building a model and implementing it. Okay, now I'm going to show you on the dataset level what that looks like. And this follows a pretty simple wizard-based workflow where you choose the header sets, the production sets, the directional survey sets, and the XYZ sets, and it's going to perform a merge on those. So that's doing things like joining the subsurface grids to the well sticks. Same thing with the production data, calculating the spacing using the surveys. The spacing that is something that we allow you customization on how those spacing calculations are done. So we calculate over 50 different spacing features, and we use a variety of different parameters in those calculations. Things like what's the date where a well goes from being a neighbor to being a child, or a sibling to being a child? How far out should we be looking to actually find neighbors? Is 2,000 foot the max? Should it be 4,000, 1,500? That's something that we allow you to configure so that it matches your own internal understanding, and so that it's specific to that basin. So this is something that we see varies kind of basin to basin what the right stuff is. But for all these different data sources that data engine will be merging together, it lets you know where you have any wells that are missing or not present across the different data sets. So here, for example, we have 2003 wells in the header set, and 384 of those were not present in the production data set. So that might be a surprise, in which case we can go investigate why those wells were missing, or maybe you know that and it's no problem. The important thing is we want to surface that information to you in service of getting the best data set possible. So when it's time to finalize it, you just go here and hit that finalize button, and just like any of our other software products, whenever it's done running that particular task, it'll put the output in a Novi Cloud and it'll send you an email. So we're really excited to be releasing this. As I mentioned, all this sources is live currently within the software and can add a lot of value. and the sets and the data sets that's coming later this quarter, possibly early next. So please give us your feedback on how things are looking so far, maybe what kind of features you want to see included in this long term going forward, what would add value for you, etc. So please let us know. Looking forward to hearing from you, and thanks for listening today.